ladies, this is the rest of the notes from simplifying exponents. And I'm just going to start by giving you three quick examples of the rules that we already learned in class. We did this, x squared times x to the fourth, and we learned that you needed to add those powers, so that's x to the sixth. And the second one was, if you had x squared, and you raised it to the fourth power, we discovered that you needed to multiply those powers, and that's x to the eighth. And the third one we did was if you had several things, several pieces inside the parentheses, let's say 2m squared n to the third, and you wanted to raise all of those things to the third power, then you just raised each factor to the third power separately, and then you dealt with each one of these individually. So 2 squared is 4, m squared cubed, multiply those powers into the sixth, and n cubed, multiply those powers into the ninth. So those are the problems that we worked on in class on Thursday. Those are the rules. Today, I'm going to give you a few more, and I'm going to start with just a couple of examples. Give you one more rule for exponents. We're going to look at dividing, and we're going to start by looking at x to the fifth divided by x squared. And we'll do it by expanding first, just like we did on the rules when we developed the earlier rules. So we can take that numerator and break it up into x times x times x times x times x, 5 of them, divided by the denominator, which will be x times x. Now, I hope you can see pretty clearly that you have an x divided by an x right here. An x divided by x is 1. We say it cancels out. All right, I have another one, x divided by x right here, also equals 1, and it cancels out. And then you can see that the only x's that have not canceled out all ended up in the numerator. There are 3 of them, so that's x cubed over a denominator of 1, because everything cancels out of your denominator. Whenever the denominator is 1, we never leave it in the final answer, so the final answer is x cubed. Now, just like Thursday, I want you to think, could I have gotten to that answer without having to show all that work in the middle? Hopefully you'll see an answer there. We'll do another example. X to the sixth divided by x to the fourth. Okay, so 6 x's in the numerator, 4 x's in the denominator, and then look and see how many cancel out. 1, 2, 3, 4 of them. When they cancel out, we're dividing, so each of those ends up being a 1, right? Leaving us with 2 in the numerator. That leaves you with the final answer of x squared. So again, take a look, beginning to end, could I have arrived at that answer without having to show that step in the middle? And just when you think you figured it out, I'm going to twist things up a little bit. And this time I'm going to put more of the x's in the denominator than in the numerator, and let's see what happens there. Okay, in the numerator I'm going to have x times x times x. And in the denominator, it will be 7 of them. Once again, I'm going to look and see what cancels out. This time, 3 of them cancel out. And in this case, all of my extra variables, all of the things that didn't cancel out, have ended up in the denominator. What ends up in the numerator? Well, remember when you cancel everything out, like if you cancel 2 divided by 4, when you reduce that down, you're not left with nothing in the numerator, you're left with a 1. Okay, that's the same thing that's going to be true here. Each of these things that cancels leaves us with a 1. All right, so 1 times 1 times 1 is 1. Now in this case, because the one's in the numerator, I cannot get rid of it. This is not the same thing as x to the fourth, so you can't get rid of it. You're going to have to leave it just like it is. So take a look at the original problem, take a look at the answer, and see if you can think of a way to get from the beginning to the end without having to show all of that work in the middle. We'll do one more. They're pretty small. All right. An x in the numerator and divided by an x to the fifth in the denominator. So my numerator is just plain x, and my denominator has 5x's. I'm looking for what can cancel. 1 cancels. All right, what does that leave me in my numerator? A 1. And in my denominator, an x to the 4th. So once again, take a look at the beginning, take a look at the end, and we're trying to come up with a shortcut so that we don't have to keep writing this out long ways. And I think you can see pretty quickly, pretty easily, that the shortcut is to subtract. The key, however, is that you need to pay attention to where more variables existed at the beginning. So if you start off with x to the 9th over x cubed, you have more variables in the numerator, so your answer is going to end up with variables in the numerator. On the other hand, if you start off with x cubed over x to the 9th, you have more variables in the denominator, so your answer is going to end up in the denominator, okay, with a 1 on top of it. All right, let's take a look at a couple more examples of this without having to expand. I have 5 x's in the numerator and 7 in the denominator. If I expand it and cancel, all 5 of the ones in the numerator are going to cancel out. I'm going to give them 1. And 5 of the x's in the denominator will cancel out, and I'll be left with 2 of them, x squared in the denominator. Okay? Y to the 10th divided by y to the 3rd. If I were to write this out, I'd have 10 y's on the top and 3 on the bottom. And 3 of them would cancel out. When they all cancel out of the denominator, I'm left with 1. 3 of them will cancel out of this 10, so you're going to subtract 10 minus 3, and I'm going to get y to the 7, right, in the numerator. If you get left with the denominator of just 1, you can get rid of it, okay? Now, that's pretty straightforward. It's not particularly hard to see. What's more interesting is when we get some problems, you get some problems where you have to do more than one thing and keep up with a couple of things at the same time. So let's do one that has some x's and some y's. And I'll do this one showing a couple of steps that you won't have to show every single time, but it's a way of thinking about it. You're going to think of this as 2 separate problems, the x problem and the y problem. And then each of those, we're going to use that little subtraction rule. So we take a look at this piece right here. How many x's that I can cancel out, excuse me. I can cancel out 2 x's, that's going to leave me a 1 in the numerator, and leave me an x to the 3rd in the denominator. With the y's, I can also cancel out 2 of the y's, that's going to leave me a 1 in the denominator, and a y squared in the numerator. And then what we want to do is just put those back together. You know, when you multiply fractions, it's top times top and bottom times bottom. So my numerator is just y squared, and my denominator is just x cubed. And ideally, we'll be able to get from the beginning to the end without having to show that separation step in the middle. So what you're thinking here is, in your head, just think about this one and see that that's going to leave you with an x cubed in the denominator. And think about this one and see that it's going to leave you with a y squared in the numerator. And then you go straight over and write your answer from there. Try another one like that. Okay, I'm going to do this without showing any work, with just writing the answer down. But I'm going to show you what I'm thinking as I go through this. So in your brain, you want to think about this piece of it right here. 1 of those x's is going to cancel, and that's going to leave me with 9 x's in the numerator. So you're going to end up with an x to the 9 in the numerator. You don't have to write that down, but that's what you're going to think. I don't think anybody can read that. Let me try to write that a little bit better. X to the 9 in the numerator. That's a little bit better. Okay? And then you're going to think y to the 4th over y to the 8th. And you're going to see that 4 of them will cancel out, and you're going to be left with the y to the 4th, and it's going to be left in the denominator. That's because there are more in the denominator than in the numerator. And what I usually do is just write a single fraction bar, and I put my whatever's left in the numerator here, and whatever's left in the denominator there. You cannot subtract those from each other because they don't have the same base. You can only do this subtraction rule if both of them have the same base. Let's look at one that's got numbers in it. Oh, coefficients, that's a much better word than numbers. Okay, coefficients. So for this problem, you're going to think of it as two separate problems. 3/6 is one problem, x to the fourth over x squared is the other problem. And you don't have to show this step after you understand what's going on. 3/6 is a fraction. You can deal with that for a long time. That's the fraction, 1/2. Just like that. Just reduce that fraction. 3/6, you just reduce it. You don't start subtracting things. This part here, with the x's, this is the new thing you just did. So you're going to be able to cancel out two of them. And where are the extras going to be? In the numerator or the denominator? And the answer is in the numerator because there were more there to begin with. So I'm just going to go right over here to this top and write my x squared in the numerator. That one is not necessary. You can leave it there if you want, but you don't have to. This answer is good. It's also good. And another good answer is this answer. But make sure you're not writing it like this, because that looks like the x squared is in the denominator, and we don't want that to happen because the x squared has to be in the numerator for this answer. Okay, I'm going to probably that problem on. We're going to separate this and think of it as two separate pieces. You don't have to write the step. You can just think of it as two separate pieces. So for this part, the coefficient part, you just reduce like you always have. -8 divided by -6, divided by +6 reduces by 2. So you get -4/3. And then you're going to look at the second part, the x's, and you're going to notice that there's 2 x's in the numerator and 3 x's in the denominator. So 2 of them will cancel, leaving none of them in the numerator and 1 x left in the denominator. And that's the only way that we write that answer is like that. Make sure that you do not make it look like it's in the middle. When it's in the middle here, that means it's in the numerator, and this is not the same thing as the answer that we received here with the x in the denominator. Okay, let's try a couple more of those. With x's and y's again. I'm just going to put a fraction bar. I know I'm going to get stuff on the top and stuff on the bottom, so I'll just put a fraction bar there. Look at your x's first. Take a look at your x's. Where are there more x's? In the numerator or the denominator? And the answer is in the numerator, more x's. So all my leftover x's are going to end up in the numerator. Remember that there's an invisible exponent right here. You can't see it, but you have to remember it's there. So 8 minus 1 gives me 7, and that gives me an x to the 7 in the numerator. Then look at the y's. Where are there more y's, the numerator or the denominator? The answer is the denominator. So when I have my extra y's, they're going to end up in the denominator. Okay. One more problem. Make sure your z's don't look like your 2's. I do it by making that little cross on them. Alright? So this is just more of the same. It just has 4 little separate problems contained in this one problem. You're going to look at each of them individually. So you start by looking at the coefficients right here at the beginning. Like that. And start right here. Look at your coefficients and reduce. -12 divided by -8. First of all, remember that a negative divided by a negative is a positive. So make sure your final answer doesn't have any negatives in it. And 12 and 8 can both be divided by 4. So 12 divided by 4 is 3, and 8 divided by 4 is 2. -12 divided by -8 reduces to 3/2. Look at your x's. Where are there more x's? In the denominator. How many more? 5 more. 6 minus 1. And so we get our x's are x to the 5th in the denominator. Look at your y's. Where are there more y's? And the answer is in the numerator. How many more are there? There's 2 more. 4 minus 2 is the 2, so y squared. And then look at your z's. Where are there more z's? Also in the numerator. How many more? 4 more. 5 minus 1 is 4. So we're going to get D. And there's your final answer. You can't combine the x's and the y's and the z's. They have to have the same base in order for you to combine them. Okay, this is the end of the notes for simplifying monomials. You should be able to now finish that worksheet on simplifying monomials. If you want to pause here and work on that, that's good. It's fine. I'm going to continue and give you some review notes. These are problems that we did back in the fall, but you have a sheet of homework this weekend that requires you to review adding, subtracting, and multiplying polynomials, and that's what I'm going to do right now. You should recognize every one of these problems. They are similar to problems that we worked back in the fall. 3x minus 5. Okay, I'm sorry. I'm going to work the problem I actually have on the piece of paper in front of me instead of making up a new one. Sorry. 2x minus 3 plus x plus 5. Now we have some new language that we can use with this. We say this has two terms. This is called a binomial. And this has two terms. It's called a binomial. So I am adding binomials. But it's the same thing we did in the fall. Those parentheses are not doing anything, so we can take them off. And then we're going to add the 2x and the x. That's 3x. And then the negative 3 with the 5, and that's plus 2. And pretty much you just have to watch out for your signs. That's the thing that we make the most mistakes on these problems. Okay, question number 2. Once again, I have two binomials, but this time I'm not adding them, I am subtracting them. This time when you get rid of the parentheses, you have to pay attention to this minus and how you deal with it. The first binomial stays the same, 2x minus 3, but we're going to minus x, and we're also going to minus 5, so you have to make sure you keep up with that sign. 2x minus x is x. Minus 3 minus 5 is minus 8. And our final answer is minus x minus 8. And then I'm going to take the exact same binomials, and I'm not going to put anything between them. And that means that I am multiplying two binomials. And hopefully you remember that we did this by a process called FOIL. We also did something that I call double distributive property, that you may have liked better, but I'm going to work the problem by FOIL. If you need some help and you want to come over double distributive property with me again, I'll be glad to do that with you. But today I'm going to work it by FOIL. F stands for first. So you multiply the first times the first. 2x times 2x is 2x squared. O stands for outer, or outside, and I usually drew it down here. 2x times 5 is 10x. I stands for inside or inner, negative 3 times x, minus 3x, and L stands for last, negative 3 times 5, negative 15. Now, there was another way some of you like to draw that picture. You did the 2x times x and the 2x times 5 on the top, and the negative 3 times x and the negative 3 times 5 on the bottom. And this is the one where people said it looked like a claw. Some people said it looked like a moon. Okay, either way you get exactly the same answer. Almost always, the two things in the middle will add together. Not always, but almost always. And so we get a final answer of 2x squared plus 7x minus 15. Now, I'm hoping that that's enough to remind you how to do these problems. If not, you're going to need to pull back out your binder and find the notes from last semester. Okay? A few more things that we did just involve plain distributive property. And I want you to be particularly careful about your distributive property, whether it's this kind of problem or whether it's a FOIL problem, and watch your signs. This is 2x times x, which is 2x squared. 2x times negative 3 minus 6x. This is minus 4 times x, minus 4x. And this is a minus 4 times a minus 1, which becomes a plus 4. And that's this plus right here is the thing that people miss the most often. So you need to watch out for your signs. And then again, we often have some things that add together, and our final answer is 2x squared minus 10x plus 4. Make sure you recognize that that's a minus 6 minus 4, not a plus 6 minus 4. Okay? All right. This problem gave a few of you a little bit of trouble back when we did it in the fall, because you tried to take a shortcut and the shortcut didn't work. this problem has a minus in it. And in order to work this problem, you have to write down this whole thing, 2x minus 3 times the whole thing again, 2x minus 3. Now, we have just learned that if we have 2x squared, that we can take a shortcut and just square the 2 and square the x. But the difference is this problem has times in it, that's why it's allowed, whereas this problem has minus in it, means that it doesn't work. The shortcut will not work. You have to actually write it out and then do all 4 steps of FOIL, 2x times 2x, 4x squared, 2x times minus 3, minus 6x, minus 3 times 2x, minus another 6x, and then minus 3 times minus 3 is plus 9. Add your 2 terms together in the middle, and your final answer is 4x squared minus 12x plus 9, okay? All right, now, one other problem that we did, 2 more problems to show you. One more, we did this, we didn't do a whole lot of them, so I'm going to go through this a little bit more slowly to make sure that you see all the steps for it, because there are a couple of these at the end of your homework. Okay, this time I'm not multiplying a binomial times a binomial, but I'm multiplying a binomial times a trinomial. Okay, 2 terms and 3 terms. It's just some new vocabulary. And there's a couple of different ways you can set this up, but I think the easiest way is to recognize you're going to take every term in the first set of parentheses and multiply it times every term in the second set. And again, I think the easiest way to do this is to do it one at a time. Take the first term, take 3x, and say you're going to multiply it times everything in the parentheses like that. Take the second term, which will be minus 2, and multiply it times everything in the parentheses. This is that double distributive property method that I was talking about. FOIL doesn't work on here. If you do FOIL on here, you miss some of the pieces, okay? All right, now you're going to do your distributive property. 3x times 4x squared is, oh, it's not 4, it's 12x cubed. 3x times x times minus x is 3x squared, make sure you have a minus, and then 3x times 5 is 15x. Then we have minus 2 times 4x squared minus 8x squared, minus 2 times minus x plus 2x, minus 2 times 5 is minus 10. These problems tend to be a little bit messier, there's a little bit more going on. Start with the highest power and write it down. Then look for anything with the next highest power, x squared, and add or subtract those. Minus 3 minus 8 is minus 11. That's the cube, the square. Now we're looking for things with just x. 15x plus 2x, 17x, and then all below at the end, that constant minus 10. So there's your final answer. Now here's one problem that I don't think I put on, anything in the fall, but it follows the same concepts, and I don't really think you're going to have a lot of trouble with it. This is just distributive property. It's just got a lot of exponents going on. Okay, so all that you have to remember on this is just to break it up and think of this sort of 2 separate problems. I'm taking 3x cubed y squared, and I'm multiplying it times 2xy cubed. Okay? Minus 3x cubed y squared, that outside, times 4x squared y. Now this step you can do in your head if you want to, as long as you're getting the right answers. Okay? And now you just put these 2 together. You want to put them in your head or on paper in order. The coefficients forward, the x is next, and the y is next. Do the same thing with the second set. Coefficients forward, the x is next, and the y is next. Okay. You cannot start lines between things here. Order of operations says you have to completely finish multiplying before you start adding and subtracting. So 3 times 2 is 6. This is x cubed times x to the first. Add those exponents, you get x to the 4th. And then y cubed times y squared, so you get y to the 5th. Minus 3 times 4 is 12. X cubed times x squared is x to the 5th. y squared times y to the first is y to the third. And there's your answer. You cannot combine these any further. If you're going to add things together, they have to be identical. So let me just show you. If I had 6x to the fourth, y to the fifth, and then I had 2x to the fourth, y to the fifth, these parts are the same. So you could add those together and say 8x to the fourth, y to the fifth. Just like you add an x and a y, an x and another x together. But because the variable parts are different, you have to leave those separate. You're not allowed to add those two together. Okay, there's your review with a little bit extra. And now you should be able to do everything that I left you for homework.